Hello everyone, this is Mr. Ege, and in this video session I am going to demonstrate your new assignment. This is going to be a Beyondmars assignment, so you're going to be creating a Mars rocket, and there is going to be a simulation of the takeoff, and probably some computations will be needed at the end, not in the very beginning maybe, but the geometry of the design will be shown in a second. Now, when you start an IPT, a part drawing inside the Inventor, uh, first thing you should check, make sure that it is a correct units. In this case, we're using metric units, but we're not using meters. We're using millimeters instead. So initially, you select the .ipt millimeter option. However, I still require ask you to just check it out and how it's going to be in reality. So select the XY plane, okay, first of all, and select a sketch, create a sketch, okay. But also double click, okay, your tools, okay, just to make sure that document settings, you get to see the document settings, and units are showing millimeters. There are many units here in system, foot, centimeter, meter, micron, and so on. You choose millimeter, okay? Angle is degree and the time is second, okay? This is essential. Once you create the sketch, okay, you make sure that you go to tools, under the tools document settings. Under the document settings, you go to the units tab and make sure you click on the millimeters and apply and close, okay? And this is how I want you to start it, okay? And then move on to sketch part. The sketch requires you initially start from the center of the sketch, draw a perpendicular line that is 50,000 millimeters. 50,000 millimeters is equivalent of 50 meters. Okay, the rocket is going to be as high as 50 millimeters. Please, it's very important. Take a note of it, or draw directly the total height and straight vertical line. Indicate it's the symbol of center of the rocket. Okay, center line of the rocket. 50 meters or 50, but most importantly, 50,000 millimeters. Now, when you zoom into the tip, that we have an arc here with the radius of 1,000, okay? And this is a 90-degree arc, okay? There's an arc command in the 2D sketch. And then you have another vertical line that is 2,500 millimeters long, okay, vertical line, okay. And after that, we need to draw another line, which is 7,000 millimeter, 135-degree angle. That particular angle here, 135 degrees, okay. And this is going to be the antenna, the part that's sticking out. Sticking part is here is going to be the antenna when you use revolve command, and the livable and the machines and the study areas are going to be in this capsule, and the capsule will have 7,000 or 7,000 millimeters or 7 meters at 135-degree angle between these two, okay, or minus 45 degree. And there is going to be a vertical line, another vertical line, okay, that is 2 meters high or 2,000 millimeters high, okay. And now here we're drawing, okay, 135-degree another line, which is 6,000 millimeters long, okay. Now, at the very tip, okay, where we are here, at the very bottom, okay, you're gonna probably need a dimension for this one. So what I'm going to do is I'll give you a dimension, specific dimension from here to here, okay, and that's going to be 2,250, 2,250, enter, okay, and that's a vertical line, and then you have the 45-degree line, okay, we're going to create another dimension and a line dimension, and this is going to be 1580, 1580. All right, we have similar line perpendicular to the initial line over here, and that's going to be again the line dimensioning. The line dimensions are easy to compute, and that's 1280. And then we have another vertical line here, which is 7,000. Another vertical at 45 degree. That's 100. This is with 90-degree angle here, and with this line, 7,000 or 7-meter long line, makes 135-degree angle. Okay, with the 2,000 millimeter line. Okay, so you can literally modify those dimensions if you like and if you feel better. But the whole point of it is, once you generate, okay, you don't need to dimension this last one. All these dimensions are more than enough, and this doesn't need to be, the fuselage part doesn't need to be dimensioned. Now, once this is done, and make sure that everything is closed perfectly, each line end of each line meets with the end of the other line. Okay, that's closed polyline configuration. You finish the sketch, and then you choose 3D model, select the revolve command. Now profile, you need to choose the profile. It's already highlighted with blue color. Click inside, select the axis, click on the button, and select the vertical line, and that's going to be generated. First of all, if you came to this point, congratulations. Okay, the three-dimensional model is created, and okay. All right. Okay, so at this point, I'm going to ask you to change your view, okay, and select the visual style of the wireframe. Okay, when you select the wireframe, you need to select the select bodies option to select the bodies, to select the entire rocket. When you click inside the area, you don't need to touch any other line. And then you go, if you go directly to 3D model and click on the shell command, that shell will enable you to select 100 millimeter of shell. Okay, you can just simply type 100 millimeter of shell. Okay, and then OK it. As soon as you do that, instantly it generates the inside walls. So now you emptied inside the rocket so that you can just modify and add the empty space, other spaces, livable spaces. This is a 10 centimeter thick wall right now. Okay, and now you can convert the entire process. You go back to view command, you choose the visual style to shade it. Okay, just like that. And then we're going to add the other things right now. Okay, so we're going to continue with the fins, and to create those fins, you need to select the plane first. So I'm clicking on this XY plane one more time and creating a sketch, a new sketch, and this is sketch number 2. I'm in the sketch number 2 now. So the first, the head fins attached to the capsule, okay, will be following the outside lines of the rocket, and you draw these two lines by just simply clicking on the line command and then selecting the points at the corners. Okay, and the next line, okay, is going to be 5,945 millimeters long, and the next line, okay, is going to be 8,750 millimeters long, and the horizontal line that comes here will give 1,200, okay, 1,200 millimeters long, and The next line will be 2,592 millimeters long, and the final line that joins the first line, okay, is 9,000. I'm not supposed to say this to you because this last number may not be exact, okay, but you make sure that your end of this line joins to the first point of the line. End of your line is joins to the first point of the line, and then it is a one closed polyline that we can extrude. And we're going to do it pretty much the same way at the tail fin, and we're going to start from this corner, draw a vertical line to this corner, and I'm not going to give you dimensions because it's already existing if you did the fuselage, okay? And again, we're in the same plane. We're going to go to the directly from point to point over here, and finally we're going to draw this line all the way to here, which is 13,226 millimeters long. We're going to go with the arc command, 3-point arc commands. You're going to choose 3-point arc command, first point and last point and midpoint arc, okay? And we're going to select the arc, first point. The last point is going to be right below the first point, and then midpoint. Either way, when you dimension the arc, it's going to be, radius is going to measure as 42,003 millimeters. Okay, then you choose to select regular line command, okay, and draw a line that's 1,573 millimeters and then 3,836 millimeters vertical line. Another arc command, first point, last point, middle point arc. And whatever the arc comes out, if you dimension it, you can click on dimension. It automatically will follow your dimensions, and it's going to be 5,837 millimeter radius, not diameter, radius, okay? And finally, the last line, I'm going to erase this because I don't want you to follow. Your last line has to be, the last line has to meet to the first line that you generated here, okay? All right, and we have, I just realized there is one line missing here. Oh, no, there is no line missing here. Okay, so this is, last line is 1,489, but it doesn't have to be. We can literally draw the last line regardless of how much is left to the end point to make sure that end point of the last line will meet to your first point. Okay, all right. So once this is done, we're going to extrude it, okay? And the extrusion is going to be, let's see, let's make it to 20 millimeters, okay? Well, that's too little, 200 millimeters, yes. And finish the sketch, all right? And we're gonna go to 3D model, go select the extrusion, and change this to 200 millimeters. And usually extrusions I go in both ways, okay? And select the first area and select the second area. Okay, and let's take a look at it if the extrusion is done neatly and okay, and zoom in. Yes, okay, extrusions are done. Okay, now we need to use the array 3D array command so that we can multiply this extrusion in the multiple ways. All right, so once extrusion is done, okay, and it may not be 100% exactly the way I have shown to you. Okay, I want to leave a little bit room for your creativity, and you can modify the design. Probably you can come up much far better looking design than what I just did. But I just give you the dimensions only as a guidelines. So some of the choices you may change is totally yours if you like something better. And talk with me too. I mean, demonstrate what you did, what happens, and what you decided differently, and so on. Anyway, I'm going to use now 3D array command, this demonstrated. So this is circular array command. Click on this one. And now computer expects me to pick the fin lines, and I have, I clicked on my cursor just on the surface of the pin. Now computer needs me to select the rotation axis. I do not have the rotation axis except the center line of the circle or cylinder. And as soon as I click on that, computer understands that I'm selecting the center line of the cylinder. And it generates 6 copies already. Do I want 6 copies? I can live with 3 copies. I can live with 4 copies. Let's check the 4 first. And 4 is not bad. But 3 is a very critical point in geometry. Probably all you know about the geometric principles, that the 3 points are actually the geometric perfect point that only one plane passes through the 3 points. There's only one. 4 points, you may have several planes passing through, but 3 points indicate that geometrically speaking, only perfect location of one single plane. So we want this to be on one single plane, so that's why I'm changing to 3 fins, okay? And so that perfect balance, perfect takeoff, and perfect landing advantage. And I click on OK button. All right, now we have, what do we have in ourselves? We have a rocket, okay, with the fin tail and head fins, okay? We're going to, before we take off the rocket, probably I'm going to make a hole at the bottom for the engines to operate properly. And right mouse button, okay. Okay, in order to make a hole, okay, I'm suggesting for you to use under the 3D model, there is a hole command here. Okay, when you click on the hole command, you're going to have a dialog box. Okay, you need to look at the focus, zoom in to the bottom of the rocket. Okay, right now. And to make a hole, select the center, because a circular hole here, there is a circular surface here. You need to select the center of the circle, okay? And with the hole command, okay, is in front, dialog box in front of you. You go to position, select the position, click on the center point, select the first hole, the simple hole, next to the word hole, okay? And then for the seating, select the first option, none, no seating. Behavior, termination, click. Okay, direction is forward, outside direction, the default direction, okay? And then the drill point is going to be perfectly flat, all right? And you choose the depth of the hole, 1000 millimeter, all right? 1000 millimeter is like about 1 meter. And finally, the diameter of the hole will be 4000 or 4 meters, okay? And then it's supposed to show you this particular look, okay? When you see this, and if everything seems to be correct to you, okay it. And now you have a hole, okay? It's good to have the hole over here because there is going to be a propulsion engine operating through this hole, all right? Okay. Let's give it a try and give me a call in the classroom if you have any problems with that. Okay, you can, or you can just watch this video a few times back and forth, and you should be able to come to that point. In the next version, next video, I'm going to demonstrate how to take the lift off. Okay, thank you very much for your time, and I'm ending my video session now. If you have any questions, please let me know.